Undergraduate Student Association. This is our second year of the program. If you don't know about the program, it's a 1-hour lunchtime program that features current speakers from our graduate student speakers from different departments and colleges across the university. They're going to share with you just some of their work today, what they focus on, their goals, challenges, and a little bit about themselves. The purpose of the program is to kind of get a discussion going. We are going to save all questions though until the end, and then our two speakers will join us up front, and you can certainly ask them any questions that you'd like. This is our 33rd Books and Bagels program, so we're very proud of it in the 2 years of its existence. Definitely spread the word. Feel free to come out every month if you can and hear about what other grad students are doing at the university. So without further ado, I'm going to introduce Dr. Hearn, who's going to be our moderator today, and she can tell you a little bit about her and what she does at the university.
Thanks, Sandra. And welcome to me as well. I do conservation research in West Africa, and it doesn't really matter actually because I'm about to retire, so I have a great successor. So I'm very happy, and I'm very happy to be introducing these two grad students today because they're both very much part of my life. Anna, the first one, was my TA. Certainly Aliki, the second speaker, is a constant and very active presence in our building. And so both of them are lively, fun to have around. Grad students, everything that makes grad students lovable, embodied in both these two people. So let me introduce Anna first. And she's, of course, a PhD candidate in bees. And you can see her title up here. She grew up in central New York, working on her aunt's farm and camping in the Adirondacks. This influenced her decision to study environment. She graduated from Juniata College in 2011 with a BS in Environmental Science and a focus in geology. She came to Drexel to work with Dr. Kenneth Lacavara, sitting right there, making sure she doesn't say anything bad. And she's interested in sea level change research over on the New Jersey coast. So go ahead.
All right, thank you, Dr. Hearn. And as you can see my presentation title here, it's Drowned Forests and Buried Salt Marshes. That is kind of the theme of my overall research project here at Drexel. But today I'm actually going to be discussing a little bit more general about sea level change and trying to focus on some of the nuances of sea level change around the world. So a little bit about myself. This is kind of why I got into environmental science. I spent a lot of time up in the Adirondack Mountains, and growing up there, the acid rain was a big problem for a long time. And I still remember the first time I saw a large fish in one of the rivers up there. Because for many years when I was younger, there really were no fish around. So camping in the Adirondacks, working at my aunt's farm, all this stuff really influenced my decision to become an environmental scientist because I love being outside, I love being in nature, and I love seeing how nature changes over time. So like I said in my introduction, I focused in geology at Juniata College, and I didn't know I was going to do geology until I got there. It turns out that I really enjoy learning about this kind of large, the Earth is a large system as a whole, and specifically looking at sediment and sediment movement. So my focus is coastal geology, which means I'm particularly interested in what's happening along our coastlines, and on the eastern coast of the United States, that's specifically looking at sediment flows, how our coastlines have evolved, and how they're continuing to evolve, especially with human influences. So my thesis kind of breaks down into two parts, looking at the local rate of sea level rise, as well as the impacts of sea level rise on the Delaware Bay Estuary. And so I'm going to, let's move to the contents here. So the content, so I want to start a little bit by going over the difference between global sea level change, local relative sea level change, and then some of the implications of my research and sea level rise in general. So, we have noticed since, as many of us know, there's been a lot of news about sea level change in recent years because sea level is rising. We are experiencing inundation of our coastlines, and we have data coming back to the 1880s showing a general increase in sea level over time. And so one of the things that particularly concerns us is that this rate seems to be increasing. And so we are particularly concerned as to what's going to happen with our coastlines in the coming years. So this is a global sea level trend. This is what's happening to worldwide waters. So what contributes to global sea level? Melting glaciers. Thermal expansion is actually a really big one. So as our temperatures warm due to climate change, the water is also expanding. And so it turns out that thermal expansion is even more of an influence in rising sea levels than we originally thought, in addition to glaciers and ice sheets. What global sea level is not is water ice. So if there is an iceberg or glaciers out over water, it is not contributing to sea level rise. It is already counted in sea level change. So when you hear that sometimes we're having an increase in sea ice, that isn't really, people are citing that an increase in sea ice means that we shouldn't worry about sea level rise as much. But we're talking about sea ice, not land ice. So if you hear that, there's some land ice is pretty consistently melting and it is really contributing to sea level change. So how do we measure global sea level? Well, the first way is using satellite altimetry. And this has only been in effect since 1992. And this is great because it actually allows us to measure really small changes in sea level all over the globe. But since it only goes back to 1992, in order to get historical measurements, we actually use an average of global tide gauges. And you can see this is a map of this map of the world. And you see in some parts of the world, sea level is rising very rapidly, and other parts it's actually falling a little bit. And I'm going to go into why it's falling in some sections in a moment. And so in order to determine our global trend, they take an average of all these tide gauges. But one of the problems with this is that the records aren't complete. There's many areas of the world, especially down here in Africa, where we do not see, where we don't have any tide gauges. And also, the tide gauges in the US only go back to 1854. So in many ways, our record is incomplete in many ways, but it does give us a good idea of what's happening with sea level change. But what I'm interested in is local relative sea level. So as we come back here, you can see that the rates around the world are rather different. And why is that? That's because how global sea level, which is the average of all tide gauges, and it's what you often hear about in the news. You often hear about global sea level change. How global sea level manifests itself on individual coastlines. That is what local relative sea level rise is. And what local relative sea level rise looks like is global sea level rise plus local geological conditions, including isostasy, shoreline slope, sediment supply, and shoreline erosion. And in a minute, I'll explain what isostasy is. So if we look at this graph here toward my left, you can see that actually in Alaska, they're actually gaining shoreline over the years. And that's true of a lot of this North America here. So they're actually gaining some shoreline. And that's because as the glaciers have retreated off of Alaska, the land there is rebounding. And so this is isostasy. It's movement of the crust and the mantle. So when you put something heavy on top of it, the crust sinks down. When the heavy thing is removed, such as here, the crust bounces back up. And so on Alaska, where there was recently glacial ice and has been melting off, that is rebounding. So they're actually gaining some land over time. Whereas if we look at Galveston, Texas, we see that they're losing land rapidly. They have a very rapid rate of sea level rise. And that's because they have a very shallowly sloping coastline. So a little bit of sea level rise goes a long way in terms of taking away coastline. They are also actually sinking. So while the land in Alaska is rebounding, the land in Texas is actually subsiding. And that's because there's some natural subsidence, but it's particularly bad because every time they extract water, oil, and gas, they're leaving voids in the earth. I think we all know that the earth doesn't really like voids. So when you leave that open space in the ground, the land's going to sink to fill in that void. So not only is the land in Galveston, Texas sinking naturally, it's sinking extra because of human influences, and it's a shallow coastline, so they're losing shoreline fairly rapidly. And you can see that New York, Baltimore, those areas are all pretty steady. But we're definitely seeing an overall trend in increasing sea level rise. So, one of the things I've noticed, especially by listening to the news, and especially by reading articles and the comments, I just shouldn't read comments in climate change articles, is that sea level rise, of course, equals shoreline loss. But the thing is, when people hear that we're losing the sea level is going up a few millimeters a year, the general response is, so what? A few millimeters a year, how does that make any difference to me? Well, the problem is that a few millimeters or a few centimeters up can equal a lot out. So especially if you have a very shallow coastline, very shallow sloping coastline, like in Texas, like up here in the Delaware Bay, a few centimeters up can erode the shoreline a lot. So in the Delaware Bay, 1 centimeter of sea level rise can equal between 1 and 3 meters of shoreline loss. So a little bit up can equal a lot out. And the difference between 1 and 3 really depends on the actual coast of the shoreline and a few other factors. So that's one of the things where I wish every time I read these articles, I wish you guys would be like, no, it does matter. So, why do we care about sea level rise? You know, so what? Sea level's rising, it happens. But one of the main issues is that as of 2003, and I know this number has gone up since then, 23% of the world's population live within 100 meters of sea level rise. That's a lot of people. There's a lot of people who are going to be affected as sea level rises. There's a lot of people who will be affected as storms move further inland. And so we're also, in addition to these people who will be directly affected, we're also losing coastal habitats and resources. So, you know, what are our coastal habitats? We've got salt marshes, which is particularly common in the Delaware Bay here, where I work, beaches, coastal forests, and barrier islands. And all of these systems provide different resources, which I'm going to go into in a moment. And so, one of the things, and this is a picture I'm going to come back to again, I think, is that, so sea level, it goes up, it's okay, you know, you got a little bit up, the system migrates inland, good. However, in the future, without human beings, it's just going to keep migrating inland. It's going to be okay. But, since we're trying to stop the sea level rise, what we're getting is a loss of these systems here. So you see the salt marsh continues. Without humans, with human influences, these systems are going to migrate inland and eventually run into barriers. And these barriers will prevent these systems from maintaining themselves. So, for example, here we have Long Beach Island, New Jersey, where there's a lot of people. Every time I see this picture, I cringe, because there's a lot of people, a lot of resources and money. And so as this beach is going to try and migrate inland, it's just going to get smaller and smaller as it bumps into the human developments here. And then we have Reed's Beach, New Jersey, which is one of the beaches I work on. And this is actually an example of the annual horseshoe migration. So one of the reasons I'm particularly focusing in Delaware Bay is not just, well, A, because it's local, which is great for our research, but also because it's really important habitat. These barrier islands, these salt marshes, these beaches, they provide a lot of habitat. And every year when the horseshoe crabs come up to me, a lot of birds come by. Delaware Bay is one of the top 4 migration spots in the world for migratory birds to stop. And then the piping plovers and the red knots, and birders really love red knots, if anyone's a birder here, always come and stop and take a break here. So then, of course, in addition to this habitat, such as the horseshoe crabs here, there's also all these other values. We have habitat, water quality. Salt marshes are very important for water quality. Salt marshes sequester carbon. They filter out pollutants. They act as giant sponges, and so when pollutants enter them, many fewer pollutants exit them. They also function to reduce the velocity of storms. So as a storm comes inland, it hits a salt marsh, it starts to slow down. As salt marsh hits beach, it hits forest, it slows down before we actually hit human development. And then, of course, we got the carbon cycle, all these nutrient cycling. And so, in many ways, these systems are very critical to maintain, even as sea level rises. We cannot allow them to simply be smushed in to human development. Okay. So, a quick second on my research. So, my research It's determining the rate of local sea level rise for a portion of the Delaware Estuary. So I'm working right throughout here. And the reason we're interested in this is because this comes back to there are tide gauges, but they don't represent all around the world. So there's actually 2 tide gauges at the mouth of the bay, and they actually show different rates of sea level change. So that encourages us to believe that there's most likely a difference in sea level rise as we go up into the bay. And we want to know what's happening in this portion of the bay so that resource managers can start preparing better. We want to give specific information to local people so that local people can prepare for sea level change. Because knowing the global rate's great, but that doesn't tell us what's happening here. That's what my research is thinking about that. And my second research is to examine the historic and geologic response to these barrier islands on the Delaware Bay. Like I said earlier, this is another picture of the 4th annual horseshoe crab migrations. These barrier islands, in addition to being great habitat, like the salt marshes, they also slow down storms. So, kind of wrapping up here, it's only at 15 minutes. What's happening in the future? Well, we're about here, and the Intergovernmental Panel on Climate Change projects that sea level is the rate of change is going to continue to increase. And that by the end of the century, we could lose up to 1 meter of shoreline. And in fact, a lot of scientists that I've been reading believe that this is actually an underestimate. So, solutions. This cannot be our solution. We cannot stick our head in the sand. We can't bury it, even though we'd like to. It's not a pretty picture. Everyone see that? So, coastal building codes. Actually thinking about how we're building, what we're building on the shoreline. How much resources do we want to really put into these shoreline areas, knowing that they will be continually impacted more and more by storms, more and more by rising waters. But is that a long-term solution? Cost. Cost is a huge issue in this problem. Retreat. Once again, cost, loss of communities. There's a lot of people who've called the shore their home for many years. What's going to happen? Stabilization. Is it effective? A lot of geologists don't feel that it is. It's also very expensive. And also there's a lot of impacts on environments and neighboring communities. So see here, when we start stabilizing the shoreline, like I said earlier, we really start to lose this intertidal, this tidal area that really gets destroyed every time we put in shoreline stabilization effects. And this is another example. This is actually a rather cheap and simple shoreline stabilization, but sea turtles, horseshoe crabs, animals cannot get to the beach anymore. So really, is this long-term effective? So in the last minute I have here, a little bit less than a minute, I wish I could say that, everything looks, that will be okay, but it's not a pretty picture. We are going to continue losing shorelines at a pretty rapid rate. So one of the things we need to do is we need to vote. Because what a lot of people don't know is that in order to live at the shore, there's a federal subsidy for flood protection. Because actual insurance companies are not going to fund people to live at the shore. Economically, it doesn't make sense. So in fact, a lot of shore people, they get federal subsidies in order for having their flood protection. And so in many ways, we are all paying for this. We are all going to continue paying as sea level rises and as flooding and storms continue to happen. So I guess I can say vote and don't buy a house on the shore. And then just click